Okay, hello everybody. Today we are going to keep working with exponential functions. We're going to focus specifically on some special key features of graphs and what special things happen to graphs when we graph these exponential functions. So, homework for lesson 15.4 is going to be on page 561, 2 through 18 even. There will be a fair amount of graphing involved since this is a graphing lesson. But before we get started, okay, quick little review here. Okay, we learned in lesson 15.3 that an exponential function, okay, is written in the form f of x equals ab to the x power. So, quick reminder, okay, that in that format, we said a stands for your initial value, and then we said that b is where you find the common ratio in your function. So just kind of reminders from yesterday. And then what we want to take a look at is we know from yesterday that the graphs of these are going to come out as these kind of exponential curves. Okay, but these curves can go different ways depending on where you have decimals, fractions, positives, negatives. So depending on where those things fall, what we have to be able to learn to do is we have to be able to describe what they call end behavior. So stick with me on this for a second as you do a few of these. These will really start to make sense, but you just need a spot where you've got some decent notes for this. So I'm going to write end behavior out to the side, and we're going to write the end behavior of each end of the graph above and below each one of these pictures. So set your paper up like this, okay, and then have a little trust in me that we're going to make sense out of this. Okay, when you guys look at this graph, hopefully you understand that there are two ends, okay? There's an end on the right side, and there's an end on the left side. So this curve, it goes out forever in these two directions. So when you are asked in your homework today to describe the end behavior of a graph, you are going to describe what happens at each end. Okay, so guys, I want you to imagine if there was an arrow pointing this way, this thing would continue to go up, 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 up forever. Okay, so basically, as we go to the right side of the graph, the right end of the graph, this thing goes up continuously. Okay, here's how you write that. You say, as x approaches infinity, y approaches infinity. That's my infinity sign right there. Okay, let me zoom in on that. So here's what I'm saying. See how on the x-axis, when you go this way, you're going to the right on the x-axis? As x approaches infinity, however far you want to go on the x-axis, this y-coordinate is going to approach infinity. And then on this end, okay, the left end is always, on the left end, this is where, see how if we go left, your x-axis gets negative, 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 negative. We say, as x approaches negative infinity, comma. Okay, look at this. Your y-coordinate, see how this line dips down here to right at 0, but it never dips past it? We say y approaches 0. Okay, if you're still like looking at this as a question mark, that's okay. Keep going. We'll get this. Okay, right side. See how the right side of this graph bottoms out way low? It's just going to keep going down, 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 down forever. Okay, so it's the right side. The right side of your x's is the positive x's, right? So as x approaches approaches infinity, okay, because the right side's always going to be as x approaches infinity. As x approaches infinity, this y goes down into the negatives forever. So we say y approaches negative infinity. So on the right end, as x approaches infinity, y approaches negative infinity. Okay, guys, left side, left end is always as x approaches negative infinity. Because when you go left on the x-axis, you're going into the negatives forever. Okay, see how this gets up to 0 but never goes past it? We say y approaches 0. Okay, keep trying. Go again. On this end, right end, okay, when you go to the right, that's when your x's approach infinity. So right end, as x approaches infinity, Okay, look at what the right end does. On the right end, this line approaches 0. Y approaches 0. Okay, left end. When you go left, that is always negative infinity. As x approaches negative infinity. So as you go left forever, look, it goes up, 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 up forever. Y approaches positive infinity. Okay? All right, hopefully we're starting to get the hang of this. Right end. When you go right, that's when x approaches infinity. As x approaches infinity, y approaches, look, if you go right, your y approaches 0, but never crosses it. Okay, left end is always as x approaches negative infinity, y approaches, and then you look. On the y-axis, this goes down, 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 down forever. Y approaches negative infinity. Okay, so basically, the x will never change. The right end will always be x approaching infinity. The left end will always be as x approaches negative infinity. You just say what is happening on the y-axis. Is it approaching 0, infinity, or negative infinity? So you want to be able to do that appropriately. Okay, and then you guys are going to notice that I kept on saying, man, like this gets right up to 0 but never crosses it. This gets right down to 0 but never crosses it. It gets right to 0, never crosses it. So we always have something that's approaching 0 in all of these. All right, so I'm sad that I'm not here to teach you this today because this is one of my favorite math words ever. You need to add this word down here, okay? And we're going to use it a lot because it's just fun to say. Let me spell it out for you first. Okay, it's this word right here. Here, I'll zoom in. asymptote. And you know how you say it? Asymptote. Feel free, say it if you want to. It's just fun to say asymptote. So you don't hear the P. It's not like asymptote. It's not asymptote. It is asymptote. Okay, so here's what an asymptote is. A line that a graph gets close to, okay, a line that a graph gets close to but never reaches. Okay, a line that a graph gets close to but never reaches. And as we do a few more of these today, you're going to start to see why it never reaches the asymptote. All right, so here we go. What you guys need to be able to do, we can sum up in these 3 examples right here. So you got to stick with me. You got to do a little work. You got to do a little calculator work. You got to do a little fraction work. We got to get through this table making business. But once you guys get done with these 3, you should be able to do anything you need to do on your homework. So, okay, first things first. Let's finish out the table. Okay, now honestly, you're kind of excited when you get decimal ones because decimal ones are ones that you actually can type into your calculator because you're expected to get decimal answers. So all you're going to do is keep replacing the x value, that exponent right there, with these numbers. So fill this in real quick. We're going to do -4 times 0.5 to the negative second, -4 times 0.5 to the negative first, -4 times 0.5 to the 0, and -4 times 0.5 to the first. So that's all we're doing. And because they are decimals, we are strictly doing this on the calculator. So you're literally typing in -4 times, and actually you could leave out the times. You could just do -4 times 0.5 to the negative second. You get -16. Okay, -4 times 0.5 to the negative first. Okay, so what did I type wrong? Sorry. I keep typing 1.5. My fault. Slowed you down there. -8. Okay, try and see if I can type again. -4 times 0.5 to the 0 is -4 because 0.5 to the 0 power is 1. times negative 4. And then negative 4 times 0.5 to the first is negative 2. All right, so here's the deal. Okay, in addition to being able to make a table and make a graph, okay, let's finish the graph, I guess, and then we'll talk about what extra we need to write. Okay, negative 2, negative 16. Negative 1, negative 8. 0, negative 4. 1, negative 2. Okay, so here's what we want to do. We want to draw this curve, and you need to draw it up to where it approaches 0, but it will never get there. Okay, so I need you guys to understand that there is an asymptote here, and here's why. Guys, you have a negative 4 in front of this, so I don't care what you get for your exponent. The second you turn around and multiply that answer by negative 4, there is no way for you to get a positive answer to this problem. Think about it. You can't take a positive decimal and multiply it times negative 4 and get anything that's not a negative. So don't let that line cross up over in the positives like, oh, I think it's going to go up here. It can't go up there. How are you going to multiply by negative 4 and get a positive answer? Can't do it. So that's why exponential functions have asymptotes. Okay? This cannot go above that line. So when you do your homework, if you make that go above 0, I would mark it wrong. Because you need to be smart enough to realize, I can't get a positive answer for this. So don't. Okay, now, here's what's going to happen. Some of the problems do just say, hey, graph this. But then they also say, identify A, B, and the y-intercept. Okay, well, A and B should be easy, right? Y equals AB to the x power. A equals negative 4. B equals 0.5. Okay, now I want you to make this connection. Guys, the y-intercept is right here. Where are you crossing the y-axis? Negative 4. So y-intercept equals, and they want you to write it as an ordered pair, 0, negative 4. Okay, so here's the deal. They're going to ask you to do that on some of the problems that they don't make you graph. Okay, newsflash. That place where you plug in a 0, which anything to the 0 power is 1, when you multiply it by this number, you're always going to get this number. 1 times this front number will equal this front number every time. So guys, whatever your A is, that is your y-intercept. If that A is a negative 4, your y-intercept is going to be at 0, negative 4. Okay? So you can do y-intercept without needing a graph. Okay, they are also going to ask you on the ones that you do graph, describe the end behavior. So let's practice. Okay, guys, the right end, this is always as x approaches infinity, because if you go right, your x approaches infinity. Okay, and then look at what y does. Y goes up, 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 but it can't hit 0. So y approaches 0 because there's an asymptote there. Okay, other end, as x approaches negative infinity, that's this way, because if you go left, you're approaching negative infinity on the x-axis. Your y goes down, 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 down forever. So y approaches negative infinity. All right, let's practice on the next two. Okay, this one, you can't just pop this in your calculator because you start doing negative exponents with that 5, it's going to give you decimals, and that's unacceptable because this is not a decimal problem. So here we go. You're doing 2 times 5 to the negative 1. Okay, I'm going to write kind of small, and I'm going to squeeze this in here. Okay, do we understand that? Okay, I'm going to write this as 2 over 1. Okay, guys, don't put 5 to the negative 1 in your calculator. Okay, not cool. Okay, you have to go, ooh, negative exponent, I have to make that positive. To make a positive exponent, I do the reciprocal. The reciprocal of 5 is 1/5. All right. This is simply 2/5. Okay, 2 times 5 to the 0 power. Guys, 5 to the 0 power is 1. 2 times 1 is 2. Okay, 2 times 5 to the first. Okay, that would be 2 times 5, which we hope is 10. Okay, 2 times 5 to the second. Okay, guys, 5 to the second is 25. So 2 times 25 is 50. Okay, that wasn't too painful, I hope, right? Done. Graph. Okay, so negative 1 2/5. Okay, this should be like literally almost on 0. Because do you see how they're counting by 5s? Okay, 0, 2 is seriously still almost at 0. Okay, 1, 10, 2, 50. Grows real fast. Okay, but when you draw this, do not cross down below 0. There is an asymptote. Because, guys, look, see that little fraction 1/5? I don't care what number you have over here and how tiny that fraction gets. When you multiply it by a positive 2, you're not going to get a negative answer. So no way should that curve ever drop below 0. It might get into tiny, tiny fractions like 1/1,000,000th, but it won't be negative. So don't cross the line and go into the negatives. Asymptote. Cut it off. Stop it. Okay. Can you name A, B in the y-intercept? A equals 2. B equals 5. The y-intercept, you can see it straight off your graph like, hey, this crosses the y-axis at 2, 0, 2. Okay? But even if you didn't have the graph to look at, you see what A is? That is your y-intercept. Every time. Okay, can we describe end behaviors? As x approaches infinity. Okay, that's your right end. On the right end, what does this thing do? It goes up forever. Y approaches infinity. Okay, on the left end, that's where you write as x approaches negative infinity. On the left end, if you go left forever, your y is going to approach 0, but it's never going to get there. Okay. Next, negative 1 times 2 to the x power. All right, negative 1 times 2 to the negative 1. Okay, guys, that's negative 1 times, okay, guys, 2 to the negative 1. Don't put it in your calculator. It is not a negative number. That means do the reciprocal. It's times 1/2. Guys, negative 1 times 1/2 is negative 1/2. Negative 1 times 2 to the 0. That's negative 1 times 1, because anything to the 0 power is 1. That's negative 1. Negative 1 times 2 to the first. All right, 2 to the first is 2, so negative 1 times 2 is negative 2. Negative 1 times 2 to the second. Okay, 2 to the second is 4, so negative 1 times 4 is negative 4. Okay, graph it. Negative 1, negative 1/2. 0, negative 1. 1, negative 2, 2, negative 4. Okay, so this is going to curve down. Okay, but do not let that cross the x-axis and go up into the positives, because I don't care what you have over here on the right side. If you multiply it by negative 1, you are going to get a negative answer. So no way should this become positive. Ever. Okay, can you list A as negative 1? B is 2. Y-intercept is always the same as A, so it's going to be 0, negative 1. And then can we describe end behavior? As x approaches infinity, that's your right end. Okay, as x's approach infinity, what's your y doing? Down, 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 down. Y approaches negative infinity. As x approaches negative infinity, which is the left end, this comes up the y-axis almost to 0, but it never gets there. It approaches 0. All right, so there's not even extra notes on the back. This should cover everything you need. So let's set up your homework paper. So you do need graph paper. Get a piece of paper ready. Get to page 561, 2 through 18 even. If everybody will get set up, you guys can pause me and come back and we'll make sure you're on the right track for homework. Okay, so on your homework, when you guys are doing 2 through 18 even. Okay, literally 2 through 8 don't even take any work on your part. So look at it and make sure we're on the same page here. Okay, state A, B, and the y-intercept. It says then graph the function on a graphing calculator. You don't have to do that. Okay, seriously, look. 2, f of x equals negative 6 times 2 to the x power. Seriously, right? A is negative 6. B is 2. Y-intercept equals 0, negative 6. I mean, seriously. That's what you're doing on 2 through 8. So there should be zero problem. Those should take you, like, no work, no space. Just write the answers down. Okay, when you get to 10, the directions do change. Okay? For the remaining 5 problems you have, state A, B, and the y-intercept, then graph the function, and describe the end behavior. So it's basically everything you did on your notes. You have to do all of those things for all of these problems. Okay, so real quick on 10, let's get you set up accordingly, and then you guys can be good to go. All right, so you're going to have to be able to graph this, which means you're going to need a table of values. Okay, so if I were you, I do want you to put at least one negative in there because that at least shows you what's going on with each end of the graph. So if you guys just want to do negative 1, 0, 1, and 2 for every table you do from 10 on, that's fine. Okay, like I said, the decimals are the ones that you guys like. Okay, so you guys can just strictly put that in there. Okay, so on that particular one, like I say, decimals are used from the get-go. So you guys are good to just kind of round that to about 8.3. You just need to be able to know where to graph it. Okay, so you're going to keep that going. You're going to graph it. Okay, so you do need to leave yourself space to draw your graph. Okay, just make sure if you want to write this down now so you don't forget to do it, you have to write what's A, what's B, what's the y-intercept, and then you have to do the end behaviors. So it's like you're going to have as x approaches infinity, y approaches what? As x approaches negative infinity, y approaches what? Okay, so you can't do that till you finish the graph, but these are the ones where you need a lot of information. So make your table, draw your graph, make sure you list all of these different things, okay, for 10, 12, 14, 16, 18, okay? So continue working on that. Make sure that lesson 15.3 is also complete and ready to grade, and we will grade both of those when I see you again tomorrow.